Hey guys, this is part 5 of welcome back to Thriver Ashish, and in this particular video will scalability, which is really very important when it comes to system design. And even if you are aware that most of the companies which take your interview of system design, like Amazon or even Uber or Microsoft, etc., they'll all focus on scaling the product very well. And how will you do that? So the basic, what is what are the basics of scalability, how scalability can be done through horizontal scaling, we'll be studying with that. So before going to definition, let's see that this is your client, let's suppose, and your clients want and you have one. Okay, you can say per node, anything. What happens when the client will make a request to server? Okay, and the server will send the response. Cool. Now what will happen, let's suppose client can be this and anything can be client. Okay, so what will happen, like server client will request and server will give back the response. Now if you'll see that there is one client and sending request and server is sending response, but when it comes to scaling the application, or you can understand that a large system like e-commerce website or even an Instagram application, Twitter or whatever, there will not be only a single client. Okay, and there will be millions of clients, those who will be sending requests like simultaneously, not million, but out of million, let's suppose 1,000 are active or 500 are active at per second, and they are sending requests, so query per second will be so high, like even more. So what happens, definitely if you have, let's suppose, a server which have certain memory, let's suppose it has ram of, I'm taking like let's suppose it has ram of 64 GB. Okay, and it has some, even there is some database all connected to that, which have some let's suppose 1 TB of memory, and has some computation power also, like how much load it will be handling, all those things. So what will happen now, when your system will grow, it, the demand basically will increase. Demand as in more requests will come. The server has to perform uh, perform action based on that request and send back the response. So what will happen here now, either if that one server is alone able to handle, well and good, but at some point of time, this will, the, the requests which are coming will outgrow the capacity of this particular server. Then in that situation you will have two options to increase the server capacity. So that's where it comes, like horizontal or vertical scaling. So horizontal is either you scale horizontally to your system, or you scale vertically. In horizontal system, what you will do, you will add more nodes. So server 1, let's suppose server 3, these are server, don't be confused with this, because ultimately server is also machine. Or in vertical scaling, either you, what you'll do, you increase the resources if there is capacity to increase the resources. For example, like if you would have dealt with PCs in your childhood, like I had a PC where uh, the RAM was only 2 GB, but there were 4 ports to increase the RAM. So what I did is, like, I bought a RAM of 2 GB and inserted in the port. And now what happened, like my CPU's capacity was 4 GB. So similarly, like, you can add up the resources, or else what you can do, you can replace it by a bigger machine. Like, over here. Bigger machine as in that might have capacity of 128 GB and processing power more, whatnot. And similarly, in case of database also, if 1 TB is not enough, what you can do, either you have option like bring more capacities database, but not very ideal in every situation. So what you'll do, you can have multiple databases. And so this is a concept of like scalability, and we'll be studying whole of this in detail. Now let's come to proper definition. So scalability in your system is ability to adapt to changes that can grow or shrink. So grow or if I'll give you a real life example here, like let's suppose now you don't want to have this infrastructure, and you are renting out ws. So you are renting out your services from aws. What will happen, like let's suppose today if you need uh, of if you need 50 GB of capacity and some xyz computational power, if you want to, if you want to increase the capacity, they will grow it internally. However, what is happening here is like aws also have multiple nodes, multiple machines, like server which is kept somewhere in their infrastructure, but they are renting it to you, and they can grow your capacity to if you want 100 GB, etc. Also, if you've started a business, you see that now you don't need a 50 GB, and there is a down, let's suppose your business is not in the peak hours and you want only 25. So you can even reduce its resources, like even you can reduce the computational power also. This is called shrinking. You can shrink your system or grow your system, it's completely on you, and that's what the scalability is. The system can scale down, scale up, and scale out. A highly scalable system prevents the system from downtime, and it ensures the quality of application of the service. Obviously, if your system is scalable, today you are handling, let's suppose 10,000 requests. Tomorrow, if it is well scalable, you can handle 50,000 requests as well. So it prevents downtime. Let's suppose your capacity is only 10,000, and tomorrow suddenly 20,000 request comes. Obviously your system will not be able to process all those things, and it will crash. As I already told, horizontal scaling and vertical scaling are the two ways from where you can implement scalability in your system. Moving ahead, let's see that what is horizontal scaling and scale. This is also called scale out. So let's understand that. Okay, here if you have this client and you have servers, server one, let's suppose, and how will you horizontally scale? So here you send request and there is response. Now what will happen when you'll increase the number of servers here? So let's see what all things you will need. Let's delete this. So here if your client is there and you have number of, let's suppose you have increased your number of servers, one server, two, three, and so the client will request, and there might be so many clients which are sending request to them. So now which server will be picked up and all those things, since you are horizontally scaling your system. So you will definitely need a load balancer here in this case. Okay, so the client will send their request. The load balancer is the one that will distribute your request to particular server as per the load balancing algorithm, and that will send back the response. that server will send back the response. So it's kind of load, it happens via proxy servers and all. So I'm just telling you that it goes, the call has to go via load balancer at some point of time. There will be a gateway, there will be a proxy server, etc. Might not go directly to load balancer, just for the example I am telling you. So you will definitely need a load balancer here that will balance out the load to different servers as per the load balancing algorithms. We'll be discussing load balancers and load balancing algorithm in detailed video. Let's look at the proper definition, that adding new servers and machines to your system so that it can cope up with new demands known as horizontal scaling. And since now there will be more nodes, therefore more load traffic can be handled, which is obviously. And now you need to have, as I told, that load balancers and load balancing algorithm to distribute the traffic to different machines. So this is a horizontal scaling. We'll be studying about its advantages and disadvantages also in more ahead. But let's see that what vertical scaling. Before going to definitions, I'll tell you like what is vertical scaling. Let's suppose you have here you have say one server, okay, and it will give you request and response. But what will happen now, if you want to increase your capacity, so you need to increase your server power. Either you can do it in two ways, like here if it is, let's suppose 64 GB iz power, here computational power, here it can be 28 GB. You are greater than that, so obviously like here more request, here there will be no need of load balancer because you have only one server. The call can go directly. So here server build server, as you can see that horizontal and vertical, there's only this difference. Like in vertical server, vertical scaling, either you increase the resources in the same machine, or you bring up a new machine, replace it with old machine with the new computational power and more resources. So let's come to vertical scaling or scale up definition. Adding more resources, here you can see, to the existing server or node so that it can cope up with demands is vertical scaling. Let's suppose if your system needs more memory, then vertical scaling will mean adding more RAM. So here you should focus on this, that if you want to add more memory, that means that adding more RAM to your existing system. And similarly, if your system needs more processing power, then it means upgrading the CPU. While vertical scaling is completely possible to replace the current machine with upgraded machine. So this was the point which I was talking about. So you should be aware of these points as well. Now let's move to advantages of horizontal scaling. Horizontal scaling is easier in comparison to vertical scaling because all you need to do is add new node here. So this is comparatively easy, and there is a reduced downtime because you need not to switch off old machine, right? To switch off old machine, so that's why the downtime will be reduced, because you just need to bring a new machine and connect to. And enhanced performance, since the load of the since the load will be distributed to multiple machines, right? Multiple machines have load, so obviously the performance will be enhanced and more connections it will. And now it will be resilient and fault tolerant. Obviously if there are, let's suppose 5 nodes and one goes down, 4 are working, correct? So the system is more resilient because whole system will not fail. You can write whole system. Okay, so these are the advantages of horizontal scaling. Let's move to disadvantage of horizontal scaling. It will be difficult to maintain horizontal scaling because uh, there will be many servers. Okay, and what will happen, since there will be many servers, there will be obviously difficulty to maintain them, and also you'll need additional resources like load balancers, uh, node synchronization balancer, node synchronization, and also communication has to be ensured. So this is purely difficult to maintain and high cost, obviously, because new machines are costly, no doubt into that. You will have to bring new machine and install it, so it will be on a higher cost rather than if you are just replacing a RAM, just creating the CPU and completely bringing up the new machine and adding to the system, so it will be more costly. And also here data might be inconsistent because here let's suppose there are 4 servers and some data is there on some server 1 or something. It has to copy to s server 2, and it has to copy server 3 and server 4, so network calls will be involved. Let's suppose if this call fails, for example, then what will happen, like s3 will be these three will be on same page, and this will not be on same page, so there might be chances to have data. So and here network calls happens, remember that this network, unlike in vertical scaling, inter-process communication happens. Now let's move to advantages of vertical scaling here. So obviously that was hard to maintain, it is easier to maintain as nodes are less or even sometimes one, cost effective because just upgrading resources, easy process and communication, as I told that since there is only single node or less, it won't have to communicate and synchronize with other nodes, so it will be it will definitely be very simple in this particular case. And as I told that there will be inter-process communication. And as I explained how data is inconsistent in horizontal scaling, here data will be consistent because there is, if there is only one node, let's suppose, then there is no need to write data some, so obviously that data will be well scaling. Let's move to disadvantages of vertical scaling. Obviously single point of failure. Why? Because you have one node or less node maybe at one node, and if it fails, whole system is down. Okay, so this is one thing. And downtime possibility, obviously, like in case of if you are upgrading, let's suppose, unless you have a backup server attached to it, this will you have to shut down the machine and upgrade it, something like that. So considerable amount of downtime time. Well, and even in case of failure also, case of failure, or upgrade, right? Unless you have a backup server. And limitations in upgradation. So a single machine can be upgraded to up to one limit. Okay, every machine will have its threshold for its resources to get upgraded. For example, if you have four nodes for four ports for RAM, and all four ports have you used with the highest maximum RAM which can be included, then obviously, and you need something else, then either you need, if you still have vertical scaling, you need to bring up the new hardware. So you can consider this as a hardware limit, right? So I'll say that these are the limitations which and next video will be studying as per our roadmap, I told in first. See you in next video. You can follow great Ish in YouTube, Insta.